Welcome to Spring LIB.
We have to check the green recurrence equation for the given sequences. So let's start with A, which is given by an is just minus n plus 2. So what we do is we write the right hand side, so an minus 1 plus twice an minus 2 plus 2n minus 9, and we replace the an minus 1 and an minus 2 with the given sequence, and we want to check that this is equal to an. So let's write this explicitly. So we replace an minus 1 with minus n plus 1 plus 2 plus twice, and then again replace minus n plus 2 plus 2 plus 2n minus 9. Now we expand everything. We get minus n plus 3 minus 2n plus 8 plus 2n minus 9. And after summing everything, we just get minus n plus 2, which is exactly an in this particular case. So we have verified that the green equation holds for this sequence. Now let's do it again. With B, I mean here an is given by 5 times, minus 1 to the power of n minus n plus 2. So we do the same thing. We replace the right hand side of the green equation, and we replace every an with the given sequence. Plus 2n minus 9. Okay. Now we compute everything. So minus 1 to the power of n minus 1 is just minus 1 to the power of n with a minus in front. So we just write it like this. And then we have minus n plus 3. And here we have, well, 2 that multiplies 5, so 10 multiplies minus 1 to the power of n minus 2. But multiplying by n minus 1 twice does nothing. So it is the same as n minus 1 to the power of n. And then we have minus 2n plus 8 plus 2n minus 9. Again, we sum. So here we factor the minus 1 to the power of n. So we have a 10 minus 5. So that's just 5 minus 1 to the power of n. And then we have all the n's. So we just have minus n. And then all the numbers plus 2. And this is in fact an as given here. And this is checked as well. Now again, same trick. The sequence is given by 3 times minus 1 to the n plus 2 to the n minus n plus 2. So again, write the right hand side of the green equation, replace with the given sequence. And now we compute again. So same trick, n minus 1 to the n minus 1 is just minus 3 minus 1 to the n plus 2n minus 1 minus n plus 3. And then here we have plus 6 minus 1 to the n plus, now this is twice 2n minus 2. So that just becomes 2 to the n minus 1. And then we have minus 2n plus 8. And then the numbers, well, plus 2n minus 9. And here again, we collect the minus 1 to the n. So we have a 6 minus 3. So that becomes a 3 minus 1 to the n. Then we have 2 times 2 to the n minus 1. So that just becomes 2 to the n. And then we have all the n's, which are just minus n, and then all the numbers, which are just 2. And this is again exactly the sequence an as given. Finally, we have the sequence an given by 7 times 2 to the n minus n plus 2. And again, write the right hand side, replace with the given sequence. And now we do the computation. So we have 7 that multiplies 2 to the n minus 1 minus n plus 3. And now here we have, well, this would be 14 times 2 to the n minus 2, but we can put the 2 inside the power of 2, so that becomes 7 to n minus 1. And then we have minus 2n plus 8 plus 2n minus 9. And now we collect the powers of 2. So here is 7 plus 7. So again, this would be 14, 2 to the n minus 1, but we put the 2 inside the power of 2, so that becomes 7 times 2 to the n. And then we have all the n's, which are just minus n, and all the numbers, which are just plus 2. And again, this is exactly an as wanted.